on here. I'm going to start with a quick video. If this video doesn't look great, feel free to hop over to our booth later and you can just click it and watch through it native in YouTube. I have to imagine that replay will get stuck. Whoa. All right. So really quick, I'm Kevin. I'm one of the founders at Unspun. I thought I'd make y'all's lives easy to start. I've seen what Unspun's done quite a bit. You would hope. Here's kind of the main things. If you're going to take notes today, just take a screenshot of this. I'll make your life easy, and then we can just go through and actually just talk about everything that's in here. So, quick overview of where we're going to go. The future, as we see it here at Unspun, the secret that we think is necessary for capitalizing and optimizing on that future. Our approach and why we think our approach, that's that secret that we talk about. Then a bit more on commercialization, our kind of core thesis and the future, and then where we think we are best within the AFFOA program. So what is the future? What do we think is coming? For us, it's very much a question of when, not if. Apparel returns to the US. Today, less than 1% sold in the US, made in the US. We very much believe in 15 years, over half of apparel sold in the US will be made in the US. So, as engineers, as futurists, this is a really cool question for ourselves. It's like, okay, what does that new industry look like? What does that future require? And at Unspun, we started thinking about this and got really aligned around our core mission to reduce the global human carbon footprint by 1% by enabling localized, automated, and fully vertical manufacturing for textiles and apparel. So we very much are driven and motivated by a sustainability calling. However, we think the best way to drive the best sustainability change is to just make the best product, make something that's better, faster, cheaper, and just happens to be sustainable. So apparel manufacturing, broadly in general, like I just talked about, we believe that this is localized, automated, and more so than just that, we believe that the future of textile manufacturing is also additive. It's additive, it's on demand, it's very fast, and it's done after the time of purchase, or as close as it's necessary to when a product is needed. So broadly, we're thinking about how do we solve the automation question in apparel. Which obviously we should start at like, okay, where's everyone else? Like, what is the world thinking about, and why isn't it working if we don't have it yet? Broadly, cut, make, trim, CMT is kind of the existing methodology for humans. If you have humans manufacturing stuff, this is the process. There's quite a lot of innovation put towards like just remove the human and recreate the process. At Unspun, we're thinking more about like, wait, if you zoom all the way out and start all over as you have yarns and you want textiles, how do you do it? And so for us, we're not saying like, hey, let's just dive in on one little step. Let's actually take an approach of combining steps. So Unspun's process is additive. It starts with yarns and it produces 3D garments. So very much going from like a world where we work in base units of flat fabric. Now we're moving to a world where we use base units of three-dimensional textiles. So for Unspun, we make tubes. We make variable diameter tubes that are completely seamless. That are woven, which is a really important distinction. And that lets us do some additional things like manipulate density, incorporate different conductive elements. But even more than that, just going back to the basics of like automating apparel manufacturing, you'll have to come visit in San Francisco if you want to see the videos or see it in real time as we're filing quite a few patents. And we already have 3 or filing a few more. But fundamentally, what else works in additive and automated, and where are we? From like 3D knitting, where you build 1 yarn at a time, up to 2 hours per garment, a really expensive machine. We're already today 5x faster and 10x cheaper. That's not like future thinking. That's not targets for where we can get in 20 years. That's today, 5x faster, 10x cheaper. because we can build multi-phase, lots and lots of yarns moving around, make products really, really fast. I'm sure you all are familiar with Shimaseki machines. Here's just a quick video, very slow. Why does this matter? Basically, if apparel is going to return to the US, it won't be a fragmented industry with lots of steps. It needs to be fully vertical, all in one place. And that's a really core thesis of Unspun, of our technology, and even more than that, how we're developing this process. We do not want to just be scientists in a lab working on tech that will never get to a commercializable level. We set out from the beginning saying we will commercialize from day one, and we want to be doing these simultaneously. So Unspun, in thinking about this on-demand manufacturing future within the US, we're already building on-demand products through the Trojan horse of a custom fit denim brand. Times Best Inventions 2019, Pop Size Best of What's New 2020. We just named one of Fastco's world-changing ideas, all around the idea of a 3D scan, which we can do off an iPhone. We've automated that tailoring process, generate the patterns, and then we send it directly to manufacturing. So we're already thinking about what that fully vertical industry looks like, and then we're also applying this new automation tech on top of that. I'm really excited to share this. This is actually one of the first times we've been able to publicly talk about these. These are the world's first seamless 3D woven pants. This is made on Unspun's manufacturing platform. This is an actual scan of an actual customer. We automatically generated what they should be, and we then sent it to our additive 3D weaving. And so, like I said, full end-to-end process. We're not just hyper-focused on one individual step. Why does this matter? To make things in the US, we need to be, like we said, just as fast and just as cheap, or even faster and cheaper than what the existing process is. So the only way we can get costs down from what it costs to produce textiles in Bangladesh, China, Turkey, wherever, is through automation. And this is something that we think about along every step of the way. Broadly, Unspun have a core hardware technology wrapped into this, but we're also thinking about how those all play together. So how do we build that on top of the data sets that then we can provide to our customers that want to do custom fit, or maybe they want to do standard fit, but we can help them optimize what those standard fits should be. So just as we're thinking fully vertical in our manufacturing process, we're also thinking fully vertical and like, how do we roll all of these complementary technologies together and have that as a really compelling consumer proposition. So for 3D weaving, automated manufacturing, again, we didn't want to start with something really high level and never get it to a commercialized side. We said, hey, let's flip it. Let's start low risk. Let's start in fashion. We can put stuff on people. There's hopefully no risk of people dying. And let's start there. And then as we build up in our maturity, then let's start jumping to military, to AFFOA and things like that. So like we said from the very beginning, like demonstrated the core tech, wanted to prove that we can commercialize it. If you can commercialize it at the consumer fashion level, you can commercialize it at the aerospace level. And then to that other point, so we've shown we 5x faster, 10x cheaper. This future is already happening. The thought of automated manufacturing returning to like high labor rate locations is not new. Shimaseki and fast retailing in Japan, they already have a facility now with like hundreds of these additive and mostly automated manufacturing machines. We think our approach is faster and better, and that's why it's more applicable at a grander scale. But this progression of moving away from a very manual labor intensive process and moving towards an additive and automated process is already something that's being done. We talked about different applications of this. Like we said, textiles and fashion is where we think we can start at the beginning. It's where we can prove our concept right from the get-go, but there's also so many more applications beyond this. We've built our tech to be material agnostic, so we can three-dimensionally weave cotton and textiles, but we can also weave carbon fiber and conductive elements and things like that. So there's so many more steps that we can go beyond just phase one, but for us, like this new method and core approach of three-dimensional weaving is very much like the base case of the future of textile manufacturing in the US as we see it. Where does that fit into AFFOA? We're experts at our technology. AFFOA and y'all within the government are experts at what your needs are. Things that we've been able to come up with so far, improve it, and what we've been able to propose in our AFFOA grant is taking our 3D weaving applications to the next step, as well as incorporating conductive yarns into those products. And then beyond that, lots of additional other areas of interest that we think are really relevant to the military. finally, on that, we're, Unspun originally founded as a team of engineers, designers, but also a large contingent of our teammates come from the exoskeleton and exobionics world. Sounds like quite a small field, and maybe some of you all have already worked with them on Talos Project and Warrior Web and all of that. So we're very much taking an engineering approach and crossing that with the tech and the fashion as we see it.
Okay. Thank you very much, Kevin. I appreciate the time. That's like fascinating technology, just as we've seen here today. So appreciate you and Unspun's participation.